come on up here, Jason. So, before we begin, Jason, why don't you tell us a little bit about yourself? What do you do, who do you work for, and what's your Ruby story?
Sure. I have part of that as part of my talk, but like Siddharth said, I'm from Michigan, and I'm a consultant. I do teaching and training and coding. My teaching is mostly focused on Rails testing.
That's awesome. When I heard the title of your talk, I said, no way, it's possible to wrangle legacy code using tests. So I've given up on that stuff. So I'm super excited to hear what you have to say about this particular problem. Please, a big round of applause for Mr. Jason Swett.
So before I start, I have to ask, did my Sheryl Crow tweet from earlier have an influence on the music? Did you guys play that just for me? So it's good to be here in India. I had an educational moment yesterday. I learned about something called Indian Standard Time. Supposedly this is about a half hour after regular time. And then Siddharth told me there's Goa Standard Time, which is a half hour later than that. But I had a scare yesterday. I was told that the party was starting at 6 p.m. And so I looked out the balcony of my hotel at 6:05, and there was nobody down there. And I was deeply concerned because I thought, who has never worked on a legacy project somehow? Okay, a lot of people didn't raise their hands. But most of us have worked on legacy projects, and they can be a real challenge. Before I talk about why it's such a challenge to work on legacy projects, I'm going to talk about the particulars of legacy projects. Here's what we're going to talk about. We're going to talk about the challenges of working on a legacy project. We're going to talk about the ways that tests can mitigate those challenges, the obstacles to putting tests on a legacy project, and then some techniques that can be used to overcome those obstacles. First, a little bit about me. Some of this has already been covered. I'm from Michigan, which is there, and Sand Lake is where that marker is right there. I'm a teacher, trainer, consultant, so I do a mix of coding and teaching classes, boot camp, stuff like that. Most of my teaching online happens at codewithjason.com. This is my website. And like I said, it's focused on Rails testing. So what are the characteristics of a legacy project? One of the main characteristics is bad code, code that's hard to understand. Code that's hard to understand is hard to work with. Legacy projects also often have few tests or no tests at all. Original maintainers who aren't around anymore. So you can't ask them like, hey, why did you do this? Why is this like this? You just have to stare at the code and guess. Poor development processes. You know, this bad code didn't write itself. It came into existence probably through some poor development practices, which may still be in place. Unknown proper behavior. This is a tough one. Sometimes there are even bugs in a legacy project that you need to leave in because everybody's used to those bugs and their workflow has been made around those bugs. And if you fix the bug, it would actually be a bug for the bug to be fixed. Lastly, speaking of bugs, legacy projects are often full of bugs, and it's easy to not only have the bugs that are already there, but introduce new bugs due to the fragility of the code. So what does all this mean? It means that changes take a long time. Things that should take 5 minutes might take 2 hours. Things that should take an hour take a day or 2 days. Things that should take a week take 6 months. Has anybody ever experienced this? Yeah. It's painful. Deployments are scary and risky. Every time you deploy something, the world blows up. And so, because deployments are always so problematic, management says, okay, last time we deployed, it was a big disaster, and we had to do all this firefighting afterward. So let's not deploy so frequently. Let's wait like 3 months or 6 months until we deploy again. But what's the result of that? That means your deployments are bigger. And since your deployments are bigger, there's more stuff to go wrong. And so more stuff does go wrong, and the cycle just gets worse and worse. And again, it's easy to introduce bugs. So what can we do about this stuff? First, I want to say that I'm not going to claim that tests are some kind of silver bullet or panacea that can solve all the problems, but I do think that among all the different things you could do to help turn a legacy project around, testing is one of the biggest positive investments that you can make. So why do I think this? One is that tests can provide executable documentation. What I mean by that is if you have tests covering a piece of code, let's say I start on a new project, I don't know anything about the code or the domain or anything, and I look at the code, I don't understand it, at least I can go to the tests and say, okay, this test is expecting that this method will return this under this condition, and so I can kind of get a feel for what the code is doing. Testing enables refactoring. So if you have a method that's 80 lines long or something like that, with no test coverage, you don't have the safety to be able to refactor it knowing that you're not changing it. But if you have test coverage on that method, or test coverage on a class, or test coverage on the whole application, you can refactor with confidence and make the code easier to understand. And after you've made the code easier to understand, it will be easier and faster. To go through and test everything is very time consuming, but if you have a good test suite on your application, you can deploy every day, multiple times a day, and because your deployments are smaller, there's less stuff to go wrong. Lastly, we have a permanence of fixes. Has anyone experienced that whack-a-mole problem where you fix a bug in one area and that bug fix introduces a new bug in some unrelated area? If you have tests on your code, then that's less likely to happen, because you fix a bug, put a test on it, that bug will never break again, and if that code does break, your test coverage will tell you that the code isn't working anymore, and you can fix it. But there are obstacles to putting tests on legacy projects. As I'm sure some of you have experienced, if management says all new code must have tests, it's not exactly that simple. Because most of the time, if you're working on a legacy project that doesn't have any tests, you can't just go and add a test. I'll build a feature that takes 30 minutes to write and then add a test, take another 10 minutes to write the test. It's usually not like that. It's usually like you have a few days worth of work that's necessary to set up the testing infrastructure in order to be able to even write your first test. You can't even have a test that says 1 + 1 = 2 if you don't have the test infrastructure in your project. So that's a challenge. The other challenge, which is even more difficult, it has to do with dependencies. If the code was written without testing in mind, it will often be written with tight coupling. So that's another way of saying just an object that depends heavily on another object, or more likely an object that depends heavily on 5 different objects, each of which depends on 7 other objects, which each depend on 3 other objects, and so on. In order to write a test for the first object, you have to spin up instances of all these different classes and their dependencies and their dependencies. Pretty soon, it just becomes impractical to even entertain the idea of writing a test. So that's a problem, but there's a way around it. I'm going to cover 3 techniques that I've used in the past. So the first is a really simple concept. It's just start with whatever's easiest. It might seem logical when you're starting to put tests on a project to start with whatever's most valuable. Like, if you have a contact page and a checkout page, usually the checkout page is going to be way more valuable to the business than the contact page. So it might be logical, it might sound logical to say, okay, let's put some tests on this checkout page, because that's really crucial for that to work. I would actually advocate for writing tests for the contact page first. Even though that test is like almost valueless, what that forces you to do is it'll force you to build up some of your test infrastructure just so you can support that test. Again, your test infrastructure work, that might take days of work. And before that, even, you have to get the whole team together and talk about what testing framework do we want to use, what are our testing goals and stuff like that. Forces you to have those conversations. Then you can write the test for the contact page, which takes 20 minutes to do. But it's all that other work that comes before, that days of work and all those conversations and stuff like that. Write the test for that easy thing, then write a test for something a little bit harder, then write a test for something a little bit harder. Work your way up to having tests for that checkout page, which might be more difficult to test. There are 2 closely related techniques called Sprout Method and Sprout Class. I first read about these in the book Working Effectively with Legacy Code by Michael Feathers. Has anybody read that book by chance? That's a really good one. I first read about these techniques in that book, and then I also found these techniques in the book Refactoring by Martin Fowler, which is a great one too. And we'll get into the details of what these are, but basically the idea is you take out a chunk of a method and move it into its own new method, or you take out a chunk of a class, take out a chunk of a method and move it into its own class. And I'm going to show a concrete example in a second. The last technique I want to share is something called characterization testing. So if you have code without tests, it's too late to do TDD. Because with TDD, you write the test first and then the code. If you have the code but not the test, it's the opposite situation. You can't do TDD. But what you can do is something I call reverse TDD, where I like to comment out the body of a method or comment out most of a class. Then I'll go and write tests first, and I'll write a test for like the first line of the method, then comment out the first line, the test will pass, write another failing test, uncomment the second line, and so on. And that gives most of the same benefits as TDD, and it can help give a feel for what the code is doing also. So here's a concrete example for Sprout Method. Don't worry about trying to read the code and tell what it does or anything like that. Just observe the size and shape of this method. So this is a really big method. It does too much stuff. It's not very easy to understand. What we want to do is refactor this method. But that's dangerous. We don't have any tests for this. We can't just go refactoring this, because how do we know it still works? And there's a chicken egg problem. I can't put tests on this either. It has too many dependencies. It depends on something called a time block type, depends on a client, depends on an appointment. I don't know what this stuff is if I'm looking at this for the first time. And we'd have to pull in all these dependencies. It'd be impractical to write a test for this. So what do? We don't want to change the code without having tests first, but we can't put tests on the code without changing it first. It's a seemingly intractable problem, but there is a way around it. So what I'm going to do is we'll focus on this first line here. So I'm going to pretend that we're all looking at this for the first time. I've never seen this before. Okay, there's this variable called a, and if param's ID is present, then we're going to find a record based on that ID. Otherwise, we're going to instantiate a new record. Okay. When we take just this one line by itself, that's easy enough to understand. So I'm going to pull that line out into its own method called setAppointment. So I haven't changed anything, and that's the significant part. I'm just copying and pasting without changing anything. Then I change the original. Instead of the code that it was before, now I'm calling my new method. And I propose that this is a very low-risk change. I don't like to change anything without having a test for it, but since we have to change it in order to test it, I want to do the least risky change possible, and I think this is pretty low risk. So what we can do, now that this exists in isolation, we can write a test just for the setAppointment method. And we don't have to worry about any of the rest of that code and that big, huge function. We can just make sure that this does what it needs to do. And then we can go to the next line in that method, or the next chunk of lines, and put that into its own method. After we repeat that several times, what you tend to end up with is code that's a lot more well-structured and easier to understand. Sprout class is almost the same exact concept. It's just instead of taking that chunk of code and putting it into a new method, you take that chunk of code and put it into a new class. So here I'm creating a class called Appointment Save Operation. I could have also called it like Appointment Factory or something like that. But the point is, same as before, I'm just taking this line and copying and pasting it into this new class. In this case, all I have is a constructor putting that line in there. And same as before, I'm changing my code from the original. Now it's calling this new class and assigning that variable just like it was before. It's just getting it from a different place. And now, since I've isolated this, I've separated it from its dependencies, we can write a test for just this. And it's much easier because we don't have all the baggage that comes along with that original method. So that's Sprout method and Sprout class. Here's an example of characterization testing. We're taking the same method, and I commented out the whole entire thing. And this, again, is the technique that I refer to as reverse TDD. I'm trying to take us back to no code. The code doesn't exist anymore. Now I'm going to write a failing test for that first line, and I'm going to kind of guess. Sometimes I can make a good guess, and sometimes I can't. Sometimes it's just too hard to understand. So I'll say, like, expect the return value to equal the string ASDF. I know it's not going to equal ASDF, but I don't have a better guess. So I'm just going to run that test. It'll fail. The result isn't ASDF. The result is 72. And so I'll say, okay, apparently under these conditions, this method returns 72. So I'll change it to that. And I'll repeat that over and over until all my code is uncommented. So in this case, I might start with that, uncomment this, and just go line by line until I've tested everything. Okay, so here are the key takeaways that I want you to leave this talk with. One, is do the easiest stuff first. Don't worry about starting with the most valuable test. Start with the easiest stuff first, because again, that forces you to have those conversations with your team about what testing framework do we want to use, what approach do we want to take, and it forces you to build your testing infrastructure. The other thing I want you to remember is the Sprout method technique and the Sprout class technique, which again, if you want to learn more about those, Michael Feathers, Working Effectively with Legacy Code, and the book Refactoring by Martin Fowler. And the last thing I want you to remember is characterization testing. And that also comes from the Michael Feathers book. You can get these slides by going to codewithjason.com/RCI for RubyConf India. And there you can get these links, the books I've mentioned in this talk. You can find those, as well as I have a blog post that is like the blog post version of this talk that I just gave. So if this is interesting to you, you can go there and find out more.
All right, thanks, Jason. Questions?
Hey, Jason. Here. Hi.
Hi.
So I have a question about the Sprout method, Sprout class refactoring. Often doing that, I found that it creates hard to remember, like classes with hard to remember names, or sometimes it creates needless indirection. So what's a good heuristic to make sure like we don't do that? Like, do you have any thoughts on that? Like basically not creating a lot of indirection through extracting a lot of classes.
Okay, so let me see if I understand. It sounds like you're saying there's kind of a danger when you're extracting classes to creating too many classes, too much indirection.
Right.
Okay. Yeah, that is a danger, but in my experience, the bigger danger is having too little abstraction. Most of the Rails projects I've encountered, they will have like one model per database table and nothing more. And so over time, like you'll have a user model that's just like 2,000 lines long or something like that. Rarely do I see the case where somebody has created too many abstractions. Usually it's the other way around. So yeah, that's certainly a danger, certainly something to keep in mind and avoid, but normally people go too far the other way.
Any other questions? I think your son has a question. All right, thanks a lot.
Thank you.
Nice. Thanks, Jason.